Okay, let's dive in. So these are just some definitions that I'm sure every textbook would mention it. But basically, when we talk about statistics, it's the mathematical procedures of organizing, summarizing, and interpreting information. So the first step, and here I want to focus on these two, organizing and summarizing. The first step of statistics, we are just trying to organize the data, trying to summarize it to get some information. That's the first step, and that's what we call the descriptive statistics. So we use graphic representations, calculations, and whatnot that gives us this information, regardless of what assumptions we can make from this. We're not making general conclusions. We are just trying to say what the data is telling us. Trying to find the mean, standard deviation, and all that. We will see that in the coming slides. So basically, the first step is this: organizing, summarizing. Once we are able to do that, then it would be easy for us to make assumptions, to start trying to make forecasting decisions and trying to do interpretation of the data that we have so that we can generalize it to a bigger population. Now, if we go back to the example of students in Canada, obviously, if we want to make the study, if we want to conduct the study, it's impossible to reach every student. So what we need to do is select a sample of students, a number of individuals that would represent the population. Now, in future videos, we will talk about how to do the selection and whatnot. So that's a separate topic. But assuming that we did the selection in the best way, so we have this sample of students. Let's say we interviewed 100 students from all over Canada. Okay, to do this survey for us. So we collected the data. So the first step would be to do graphic representation, see where which region has more students with anxiety versus other regions that have students with less anxiety and whatnot. So we can do this comparison, and then once we have gathered all this information, then we can make an assumption about all students of Canada. So if we see that the anxiety strikes when exams are near for like more than 60% of the sample that we have, then maybe we can generalize that for the population. But it's not as easy as it sounds. We need to make assumptions and validate it. We need data to validate that. And that's what inferential statistics is all about. So for inferential statistics, it's the study of samples that allows us to make generalizations about the population, the whole population that we will be studying. Any questions on the difference between descriptive and inferential? Okay, I will assume everyone is. Yeah, this is just an initial definition, so nothing complicated here. Where's my
I have one question though, if I
Yes,
may.
yeah,
So in
yes,
terms of
of course.
descriptive statistics,
Yeah,
do we assume that we have a smaller population? That's why we can do the graphic presentation and it would give us like a kind of valid and accurate information, or is that also applicable to once we have the sample and then we can use the descriptive statistics tools to I don't know if my
that's a
question
good
makes sense.
question. No, that's a good question. Thank you. So basically, the assumption in descriptive statistics is that we have access to the whole population. So we assume that the sample is the population. So even though we will be in the descriptive study, we will be working with, just a sample of a sample, a number of individuals. So we can't work with the whole population. It's impossible. So usually what we would have is a set of data that is collected from a number of individuals. So we would never have access to the whole population. As I explained earlier, it's impossible to, and it's too costly. Even if it were possible, it's too expensive. So it doesn't make sense to do this operation. So the assumption here is that in descriptive statistics, we assume that this is our population. So we're just trying to make the data talk to us by organizing it, summarizing it, getting this information. And then once we have all that, then we can say, okay, well, if this number of individuals behave this way, we can assume that the population behaves the same. So let's see if the data can strengthen the assumption that the sample is proven. So let me give you another example. Let's say that we are conducting a review of caffeine intake, caffeine intake all year during the year for students. Let's take the same population. Okay, so this time we're interested in caffeine intake, and the sample shows that the average student drinks 2 cups a day. I'm just making stuff up here. So this is what I see in the sample. So we interviewed 100 students, and the average number of cups that they have per day is 2, through our calculations and whatnot. Now I can't just say, okay, so this is true for the whole population. I can't just make this generalization up. I need to do some calculations here. So that's when I need to move to inferential statistics to generalize this information and do hypothesis testing. Does that make sense to you?
Absolutely. Thank you very much.
Thank you. That was a good question. Okay. So some vocabulary here. So when we talk about population, it doesn't necessarily mean people. So population is the individuals of interest in a particular study, and this means that it's the whole entity that we're trying to understand. So this doesn't necessarily apply just to people. So the individuals could be, the bottles of soda in a manufacturing company. It could be clients for a certain financial company and whatnot. So the individuals doesn't necessarily mean a human. It could be, like animals in a shelter and whatnot. So it really doesn't matter whether the individual is an actual person. Here, the population is defined as what do we need to understand? What entity are we trying to understand the behavior of for a specific reason? Either we are interested in launching a new product and we need to know, whether the product would be a good hit for a certain demographic. So we're trying to understand the demographic, how it works, or we're trying to evaluate the efficiency of a certain machine. So we're taking a sample of products or finished products and evaluating whether they are defective or not to know how good the machine is, whether it requires more maintenance, less maintenance, and so on. Does that make sense to everyone? That when we say population, it doesn't necessarily mean a person and a number of people, because this is a very important distinction. Okay. Now, when we come to a sample, it's what it's a number of individuals selected from the population. So from the manufacturing company, I can select a number of bottles that I will be testing, or from all the clients of a certain financial institution, we select several clients to ask on a survey. and those would be representative of the population. As I mentioned before, the word, and I will, let me just highlight this, represent, this is a very important keyword, because the way a sample can, the way sample can represent a population is very specific. So there are methods for selecting individuals for a sample, and that will be covered in the future, but not in this first part. Finally, the variable is a characteristic or a condition that changes or has different values for different individuals. So that's what we're trying to evaluate, like caffeine level intake, like the number. That's the variable, because that varies from one individual to the other. Level of anxiety, that's also a variable that varies from one individual to the other. The state of the bottle, the soda bottle, like is it defective or not defective? So that's also it varies from one bottle to the other. Any questions on these definitions? Okay. We also talk about parameters and statistic. The difference between the two is that parameter refers to a value that describes a population, and statistic describes a sample. So that's so when you hear the word statistic, it's usually to describe a sample, because we can that's usually where we get the information from. But and this is specifically if you're looking into textbooks. So textbooks would refer, when you see a parameter, that's definitely something about the population, like the mean of a population. And this is usually possible for for governmental organizations that have the information of the whole population, so they can have this information about the parameter. But for researchers who have only access to a sample of the population, so they would be talking about a statistic. So these are, so it's the same thing. It's a certain value, could be the mean, standard deviation, could be and whatnot. So we will talk about all these parameters in the fourth section. In the fourth section. So we will be discussing more what these parameter or statistics are. And finally, data as our so data is a plural name. So it's the measurements or observations. So and you see here when I say measurements, it's not these measurements could be linked to a product or an individual. Okay, so and it's the whole set of these observations collected and stored. It could be stored on an Excel file, could be stored in a VBA database, could be collected from a website, collected from a third party. So there are third parties that are selling data. So that's and that's why you want to be careful about the data that you put in the websites. So yeah, be careful about that. Finally, datum is just a single measurement, but we rarely use the datum. We usually use data to refer to a set of observation, because we're not interested in just one measurement, because one measurement doesn't make any sense. If you tell me that a person that someone that has 10 cups of coffee a day, that doesn't mean anything unless you put this person with other individuals and then compare the intake of all these individuals. Does that make sense? Yes, Shalini?
Yes,
Shalini, you
Paula.
have a
So,
question?
yeah, I have a question. So, the statistic and the parameter, yeah, I get that. It's like a value that describes a sample, but the term value, it's kind of tricky here. I just wanted to understand if the statistic is referring to the value as in the number of each number of observation, or is it referring to the the central tendency test or something that we might do, like for example finding the mean. That's also a value at the end of the day. So is the statistic thing referring to the mean, something like that, or the individual observations in the data matrix? Like, do you get what
That's a
I
good
mean, or am
question,
I
Shalini.
confusing?
Yeah, I get you. I get you. Thank you, Shalini. That's a very good question. Actually, that's what we will be discussing in the fourth section here. So if you look up, you can see that the fourth section is statistical parameters. So that's, we will be discussing all these parameters. And you're right, it refers to, either calculating the mean, calculating, standard deviation, a certain value that relates to for parameters it relates to the population. But because we are in descriptive statistics right now, that's why we will be talking about statistical parameters that relates to the sample, not to the whole population. So we will be talking about the measure of tendency, measure of dispersion, position, and whatnot. So you're ahead of the curve there. So we will be discussing that. But
I'm
thank
sorry, I
you.
just got a bit confused because since it's value,
No.
I got confused if it's like the individual value that's there inside, like number of observations, or is it the test, like the mean, as you just said. Now I got clarified. Thank you so much.
Okay, I'm glad you clarified. Okay, any other questions?